If you are a JMD student, you are a star. Absolutely. For sure true. But did you know that you can also buy your own star? Isn't that great? Just go to the Canadian Star Registry and pick up a package, and it's all yours. And that would be great, but how would you locate it in the sky? That is what we're talking about today. So if you want to find your star in the sky, you need two pieces of information. Number one, you need to know which direction it is. Which direction should you face? So you can do this just by using a compass. Sometimes you might pull out your phone and you can use the compass on your phone, and that would be great. The next thing you know, once you know which direction to face, is how high is it in the sky. And so we're going to use a coordinate system called the azimuth altitude method. So azimuth is just kind of like using your compass to figure out which direction you're going to point, and altitude is how high it is above the sky. And so azimuth is like your compass direction. It's between 0 and 360 degrees. So when you're north, that is 0 degrees. And then as you move around to east, that would be 90, because we got a nice right angle right here. And then if you were south, that would be represented by 180 degrees. West is 270. And then we almost get it back up to this point. 359 would be right here. And then we're back to 0. So it's a number system. It's kind of like with graphing, your x coordinate comes first, then y. And we can use our azimuth, but it's just a number between 0 and 359.9 repeating to show which direction we are going to face. Altitude, how high is it in the sky? This is a number between 0 and 90. So 0 is directly on the horizon, and then as I move up, I increase in degrees. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then probably up to about 45 right there, 70, and then 90 if I'm talking about an object that is directly overhead. So it's between 0 and 90 degrees, the horizon is 0, and if there is an object that is 90 degrees right above you, that has a special name called the zenith, the point directly above your head. So first we name our azimuth, our what direction we need to point, and then we talk about our altitude, how high is it in the sky. That's one way of locating stars. There are two instruments that you can use to do this. There is the Astrolab, that is a device that can measure altitude, and you can just use a compass. Just use a compass on your phone to get your azimuth. Okay, so yeah, these are all time and location dependent. They change depending on where you are in the world. So the azimuth altitude is going to be different than it is to a person who is in Hawaii or China, because the directions are going to be vastly different, and well, I guess if you're in China, we might not even be able to see the same stars at the same time. Actually, that's not true. But if we're in different hemispheres, it makes things a lot different. We can't see exactly what the southern hemisphere is seeing, just depending on the Earth blocking out certain stars. But the point is, it's time and location dependent. Time of reading, yeah. So as time goes on, I mean, the Earth's always rotating, right? It's always spinning, and so those stars are going to appear to move. And so, yeah, even if you look through like a backyard telescope, once you get focused on like a planet or a star, you'll notice that after a few moments, it might be out of your field of view because the Earth is always spinning. Some telescopes, computerized telescopes, can self-adjust and kind of like maintain that object in your field of view. But if you have just like a standard telescope, you're only going to be able to view that object for I don't know, like a minute or so before it's moves out of your field of view. So planets, they can move significantly within days or weeks, and so their motions, I guess, maybe are not as predictable as the stars, just because they can appear to speed up or slow down because they have this elliptical path, and so as you're going to find out in physics 20, these planets, they're going to sweep out equal areas in equal time. That idea is beyond the scope of this course, but the point is that they are going to appear to speed up and slow down, and so not always as predictable as we would like things to be. Elliptical just means like this oval, squash, circle type of orbit. Something like that. Take a circle and you squash it. And there's your ellipse, which makes your elliptical orbit. Okay, frame of reference systems are quite useful. Set of axes, kind of like a coordinate plane, Cartesian plane for graphing. Your XY plane, maybe that's a better way of describing it, an easier way. Yeah, so we need some type of frame of reference. Sometimes when we're talking about space, we're using other stars as our reference point as well, so we can, to help us locate things. In the past, there have been two types of models for, I guess, maybe the universe or solar system. Solar system is maybe a better word here. But there was the geocentric model. So for a long time, humans thought that the Earth was in the center. Geo kind of relates to the word, to our Earth that we live on. Centric, center. Geocentric model, Earth is in the center of the solar system. And so, yeah, that's basically it. That's what humans thought for a long time. And it's only been like 500 years ago that we've thought different. So the heliocentric model is a wee bit different. It's actually hugely different. The sun is in the center, and the planets revolve around us. Now, the planets seem to wander back. They do like a slight wobble and this is just based on observation that I guess ancient astronomers made. And so Ptolemy presented this idea that maybe the planets are moving in their own little circles, epicycles as well. But even this isn't the case, but this is just a theory that was proposed. Okay, whoops. No, sorry, this is still the geocentric. Heliocentric is right here. This is where the sun is now in the center, as discovered by Nicholas Copernicus. And so, yeah. Sun is now in the center. Looking at, if you look at a planet like Jupiter, even through a backyard telescope, you can see that it has its own moons. And this is another observation that led to this model as well. If there's moons revolving around Jupiter, then maybe Earth is not the center, and so yeah, this seemed to, once new information was found, this theory fit the new information a lot better. That's it.